the guy who's driving around told me about a story about his advisor. He used to teach calculus, and when he got to the integration test, he would have the integral of dx on the test. And invariably, a bunch of students wouldn't get it because they just haven't thought about it, you know? I don't know how to integrate dx. What's that, you know? And so what he'd do is he'd bring his 6-year-old grandson into class, stand him up in the front of the room and go, "Son, what is the integral of dx?" And the little boy would go, "The integral of dx is x plus a constant, sir." And then he would look at them and he'd go, "You idiots. Even a 6-year-old can do this." It's great. I love that story. Let's see here. I've told it twice today. So this is uv minus integral of v du. What's u? So we've got x ln of x minus the integral of x times dx over x. Oh, look, it looks like we're going to need to know integral of dx again. As you can see, Liate has served us well. Okay. Liate, it sounds like something some of those like health nuts might make you try to drink. They're like brewing it in their fridge. You get grass from their backyard and mix it with cat pee or something. I don't know. It's holistic nonsense. All right, sorry. I digress. Ask me what I think of multi-level marketing. All right, sorry. No. Don't ask me. Some of you are probably involved in that. Anyway, friends don't sell friends stuff. Let's see here. Yeah. Oh, okay. So those are my examples. Any questions then about integration by parts? I will do more integration by parts next week. It is in your homework. It is due, allegedly Monday. Would you like to have till Tuesday?
Yes.
All right. Yes. So you can thank the Trump for that. We're just a little bit, you know, if we didn't have snow tomorrow, I would just spend about 50 minutes tomorrow just doing integration by parts after integration by parts after integration by parts, and we'd be good to go. But we're just a smidgen behind, so I will give you an extra day. That said, are there any questions about the homework? Yes, sir? Sorry.
Section 7.8, question 30, it asks you to prove something like that the second derivative of this
Sure.
combination equals something that doesn't include constants at all. So that was kind of, I had no idea how I was going to go about it.
Oh, so that strikes to the heart of the, I mean, no questions about integration by parts for now? I mean, we'll talk about it again. By the way, I hope to I'll post you guys a link. I have, I don't know, at least an hour or so of me blathering on about integration by parts for my applied calculus class last semester. And it is at you might have to put, if you could like watch it on like double speed, it might be good. Because you have to talk very slow to that class. It's bad. It's bad in there. It's bad. It's bad. But getting back to your question, the real question you have is what's a differential equation and what's a solution, right? So, like for example, y prime prime plus y equals to 0. What does it mean for something to be a solution to that? For example, if I let y equals to sine of x, well then I can calculate y prime is cosine of x, right? And y prime prime is minus sine of x. Hence, y prime prime plus y is equal to minus sine of x plus sine of x, which is equal to 0. Which goes to show you that when you plug in the function to the differential equation, it works. So that homework question is the same thing. All you got to do is you got to look at the differential equation, which is y prime prime minus c squared y equals to 0, and you plug in, I'll do one of them. For example, if I look at y equals to, let me skip the constant out front, just write hyperbolic cosine of cx. What's y prime? c times the sinh of cx, and y prime prime is c squared times the cosh of cx. So what happens when I look at y prime prime minus y, c squared y? What do I get? I get 0, right? Because I get c squared cosh cx minus c squared cosh cx, which is 0. So, I'm sorry. Yeah, that one's not too bad. What was your question? I'm sorry, he asked. Number 50. And what was your question? Okay. Well, the constant, if you differentiate constant times something, it just rides along. So the only difference would be we'd have an a in front of what I just did. It's really, yeah. Number, what was it? 50 of 7.7? So what was your question about that? Yeah. So what did you see you had to make a U-substitution, right? And what was your U-substitution? Oh, nope, that's not the way to go. Yeah, that I wouldn't, I mean, no. I mean, that's the other reasonable guess. The way to look at this, though, is this is the integral of something over something. And so if I let u equal to e to the minus x, then du, well, I don't want to work it all out, but this is the u substitution you want to make there. I will give you this advice, though. Some of you are tripped up on this. When you change bounds, right, that would be like e to the minus natural log of 2. So, by the way, this is going to give you like a minus du over the square root of 1 minus u squared, so it integrates to inverse sine of u. Yeah. Now, some of you are like, well, that's minus 2. Why is this minus 2? It's not legit. This is e to the ln of 1 over 2, which is a half. And we can take natural log of a half all day long, no problem, right? I mean, it's negative, but there it is. So that would be my warning. That little bit of algebra is important for that problem. Yes, sir?
I'm just wondering what you prefer to do. Do you prefer we change the bound? If oftentimes I take general integral and just do it without bound and relate it to the end, is that okay?
Yeah. What you can't do is leave the bounds in x and write u. There are various ways to do it. As long as you do it correct way, I'll be fine. What are correct ways? Well, we'll find out. Sorry, I'm being a little bit vague there. Other questions? I have a pair of examples that I'd like to show you. Just because we haven't done enough integration yet, and I'd like to just kind of start a discussion. And so there's an algebraic skill that some of you are better than others at. Maybe you've done it, maybe you haven't. I don't know. Dx over x squared plus 4x plus 5. We're going to work this out. And once we're done with that, we're going to work out the integral of dx over x squared plus 4x plus 3. All right. So how do you do something like this? I mean, you're like, well, that's not quite anything we've done, is it? Well, I guess not quite, but what we can do is we can rewrite this as x plus 2 quantity squared plus what? How many people agree with 1? Right? This is completing the square. Now, if you're not sure why that's the case, it's because if you take x plus 2 and you square it, you get x squared plus 4x plus 4, right? So to be fair, in order to get back to 5, I have to add 1. This is the technique of completing the square. And then I make a U-substitution. This is the integral of du over u squared plus 1, right? U equals x plus 2. Du is dx, right? And what is that? Inverse tangent of x plus 2 plus a constant, right? Bam. So when we complete the square, 3 things can happen. You can end up with the square plus something squared, the square minus something squared, or just it's a perfect square, right? You now know all the functions you need to integrate reciprocals of quadratic functions. It could be an inverse tangent, like this. What happens with this example? Again, same song and dance. Complete the square in the denominator. X plus 2 quantity squared. This time what? Minus 1, yeah. And so this is like the integral of du over u squared minus 1. Right? What did we learn today? The derivative of inverse hyperbolic tangent is 1 minus x squared. See, it's not quite what we want. Right, so this is minus the hyperbolic tangent, inverse hyperbolic tangent of u plus a constant. Assuming that we have the right range of x for this to make sense. I mean, this formula is only good for x between minus 1 and 1. But let's assume that for the sake of discussion here. So there you go, minus inverse hyperbolic tangent of, well, I mean, not that x plus, we don't need x plus, when's this going to be true? We need minus 1 less than x plus 2 less than 1. That's when this calculation is going to be okay. Otherwise, we'll need to do something else. So anyway, I'll try to work more of this in. I mean, next week we're going to do lots and lots of integration, not so much background anymore, right? I mean, we'll do so much integration next week, you'll just never want to see an integral again. It's going to be awesome. I'm assuming we won't have class tomorrow. We'll see. Yeah.
I like integrals because you can find the area under a curve.
Ah, yes. So thanks, guys.